Let's use sine and cosine in an applied context. Suppose Laura is skiing on a circular ski trail that has a radius of 1.4 kilometers, and Laura starts at the 3 o'clock position of the trail and travels in the counterclockwise direction. Like any other word problem, let's start by drawing a diagram just to make sure we know what's going on in the situation. So we've got a circular ski trail, and the radius of the ski trail is 1.4 kilometers. Laura starts at the 3 o'clock position, and she's traveling in this counterclockwise direction. So, if Laura sweeps out 0.6 radians, what is her location relative to the center of the ski trail? So again, if we draw this out, we've got our ski trail with a radius of 1.4 kilometers, and we've got the center of the ski trail here. And usually when we do this, we kind of imagine a vertical diameter and a horizontal diameter going through the center of that circle. So Laura sweeps out 0.6 radians. We could draw something like this. So she starts at the 3 o'clock, she sweeps out 0.6 radians. It might look something like that. And then she ends at this final point right here. So we imagine an angle here, and we'll draw that in. So initial ray at 3 o'clock, and then our terminal ray passing through Laura's final location. We know that this angle has a measure of 0.6 radians. What we want to know is, what is Laura's location relative to that center point? We know that Laura is some distance to the right of the center of the ski trail and some distance above the center of the ski trail. And her distance to the right of the center of the ski trail, we know, is cosine of 0.6 radians. So this cosine of 0.6 tells us her distance to the right of the center of the circle, but measured in radius, or radius lengths. We know that each radius length, or each radii, is 1.4 kilometers long, so our distance to the right of the center of the ski trail in kilometers is 1.4 times cosine of 0.6. Now we can compute values for these things. So cosine of 0.6 is roughly 0.825, and 1.4 times cosine of 0.6, which is a number of kilometers, that has a value of about 1.155. So she's about 0.825 radii to the right of the center of the ski trail and about 1.155 kilometers up to the right of the center of the ski trail. Now on the other hand, her distance above the center of the ski trail, we can use the sine function to find that. So sine of 0.6 tells us her distance above the center of the ski trail, and that's measured in radii. However, the radius of the circle is 1.4 kilometers, so 1.4 times sine of 0.6 tells us her distance above the center of the ski trail, measured in kilometers. Now each of these expressions we could plug into a calculator and find a value, or we could just represent them in that way. On the other hand, if Laura travels 2.8 kilometers along the ski trail, what is her location relative to the center of the ski trail? Start by drawing a diagram. We have our circular ski trail with a radius of 1.4 kilometers. She starts at the 3 o'clock position, and then she travels 2.8 kilometers along the ski trail. So that's about 2.8 kilometers. And then she stops at some location up there. Again, we imagine drawing in our angle that she sweeps out. She starts at the 3 o'clock, ends up here, and so she sweeps out some number of radians, theta. We're not told how many radians she sweeps out, but she subtends an arc that's 2.8 kilometers long along a circle that has a radius of 1.4 kilometers. So this number of radians is 2.8 divided by 1.4, which is equal to 2. So she sweeps out 2 radians. Then, again, we know that she's some distance to the right and some distance above the center of the ski trail. And her distance to the right of the center of the ski trail is represented as cosine of 2, and that's a number of radii. And to find the number of kilometers, again, we just do 1.4, the radius of the circle, times cosine of 2, and that'll give us a number of kilometers to the right of the center of the circle. Now we see that she's to the left of the center of that ski trail, so both of these values right here should have a negative value. If you plug those into your calculator, you should get a negative number out there. On the other hand, her distance above the center of the ski trail, We can represent that as sine of 2, and that's a number of radii. Radius of the circle is 1.4 kilometers, so 1.4 times that number of radii should give us the number of kilometers above the center of the ski trail. And since she's above the center of the ski trail, both of these values should be greater than 0.